Hello, hello. Can you hear me? Please respond. Okay, thank you. Let's wait 2 to 5 minutes. Then we will start. Can you introduce yourself? Please your name. You can text. Right, right. So wait 2 to 5 minutes. Then we will start.
No problem.
Okay. Can we introduce ourselves one by one?
Yeah, see, I'm a faculty in a university. Uh, I started developing interest in solar energy. That's why I started thinking of attending this course.
Yes,
Okay, so I'm a physicist. Basically, I teach physics.
okay, sir. Okay. Nice.
Go from Gurugram. Okay, I think have you heard the name BML Munjal University?
Sorry, sir.
BML Munjal University. It is in Gurugram district. Okay,
Okay.
I am working here only. Okay.
Okay, sir. Okay. Next, please. Anyone?
I would like to ask you one thing. Is there any, uh, is there any, like uh, solar thermal, station, so that actually we may visit that place and then have real life experience kind of thing?
You can visit IT Kanpur.
Do you have it in IIT Kanpur?
There is a thermal. Let me find, then I will tell you. I have
Please, please. So that actually even I am interested to take our students also from here actually to visit that
okay,
place.
okay.
You
So
know,
please,
please let me know.
can you send me a email? This is my email ID. You can write and
Yeah,
it.
I'll note down your mail ID. Yeah, sure.
Okay.
Thank you, thank you.
And then what is your query? I will find.
Yeah, great, great.
And I will discuss also Professor Asif. This is a course
Oh, sure,
instructor,
sure. Yes, yes.
also available at IIT Kanpur.
Kanpur is a little far away, okay, right?
Mhm.
Okay, from our place. No problem, but however, it will be helpful.
Okay, sir. So let's we start. So I am Harishankar student. A primary school at IIT Roorkee under the supervision of Professor K. Yadav and also co-guide Professor Asif Garg at IIT Kanpur. And this is course instructor by Asif Garg, course is solar photovoltaic. So let's start discussion. First, Are you visible my slides?
We can see.
Yes, yes. Okay, thank you. So we know the solar radiation. Solar radiation comes through the atmosphere, and here will be the reflection, scattering, absorption, so many phenomena are there. So this solar radiation power per unit area generally measured by watt per meter square. This is the SI unit. And the solar radiation Earth surface depend on the tilt measuring surface, height, sun above the horizon, and atmospheric condition. You know, sir, I think already discussed in class, but little bit brief recap. And the study of measurement of solar radiation has several important applications, including the prediction of the energy generation from the solar power plants and heating and cooling loading of buildings, loads of buildings, climate modeling, weather forecasting, passive time, daytime radiative cooling application in space, and etc. So this is a recap, and we can measure solar global irradiation by pyrometer and directly normal radiation or beam radiation measured by pyrheliometer. Okay, so please remember this name also. And this is the spectrum of sun. At sea level, we can see red. Why this is less? Because atmosphere can absorb, radiate or scattered. So, and this is without atmospheric condition above the atmosphere. And black one, black body spectrum. First region is for UV, second is visible, then infra according to the wavelength. And there is the irradiation watt per meter per nanometer. And next important term is air mass coefficient. And we can define air mass coefficient like that: path length taken, path length taken by the light through the atmosphere, which is normalized to the shortest possible path length when sun is zenith. We can see with respect to this, when sun is zenith, perpendicular to the above, and after some time we can see this is the zenith angle, and we can define this air mass coefficient 1 plus shadow length divided by height square taken square root. This is air mass coefficient equal to 1 upon cosine theta. So totally defined by AM cosine Z cosine zenith angle. So remember this formula also. And when solar cell is like that efficiency 26 or around perovskite or 25, but there should be the universal constant, because an evening the evening to morning, so radiation is different and different place. So there is a universal constant, or we can take an average. So is efficiency defined by AM 1.5. Do you know? So then SI unit for solar cell efficiency measure second average, and which is AM 1.5. Okay, and what is the power? This anyone? Power for this AM 1.5.
Maybe around less than 1,000 watts, maybe.
Generally taken 1000 watt milliwatt per centimeter square.
Okay.
So for AM0, this is above the atmosphere, outside atmosphere, approximate black body 500 Kelvin refers to as M0, meaning zero atmosphere. Okay, this is useful for space application like that satellites. M1 spectrum after traveling through the atmosphere, sea level, the sun directly already refer to AM definition M1 or zero angle, zenith angle. When sun is zenith, 1.1 25 degree. When sun is moved from the zenith, 1.5 2 to 3 38 close the horizon, close to horizon. Okay, so can you find theta for 1.5 AM?
48.2 degrees.
But we can generally find like that taken 1.5 and we can find theta. Okay, so another procedure 2 3 any we can find theta according to, yes, this is the formula, simple.
Okay, the theta, whatever you have written, that is 48.2 degrees.
Yes,
Is it the theta z, right?
theta this is notation theta z.
Okay. Okay.
So another question, let's discuss the factor influencing the solar irradiance on the earth surface is R. Absorption and scattering of the air, wavelength of the radiation, type of the receiving surface, time of the day. Please answer if you know.
Of course, absorption absorption will be there with the atmosphere. Scattering by will be there.
Yes, absorption is scattering.
Time of the day, definitely.
Which
Time of the day, sir. F.
time of the day? Yes.
Uh, because sun is not same at the each time, right? That's why I'm saying,
Yes, you are right.
Of course, then day of the year also, because in the winters you will having
So answer is
wavelength also.
A, B, C, and F. You are
And that's
absolutely right.
great.
And wavelength is not depend. The according to wavelength, energy is different, but this is not influencing. Solar radiation measuring what is the SI unit?
Is kilowatt per meter square.
1 unit. Yes, please again.
Kilowatt per meter square.
Yes, kilowatt per meter square. This is the SI unit. We have already discussed in previous slides. Yes.
Yeah.
First, watt per meter square or kilowatt may be taken. But generally, SI unit is watt per meter square. Kilo may be the quantity is much higher, so then we can generally take kilo or something else. But watt per meter square should be there.
Yeah.
Yeah. Beer impact flow is used for
Used for absorption, right?
scattering or no. Yes,
Absorption.
absorption. Other maybe please answer. Please discuss.
Sorry, others also, please.
Please interact. So beer Lambert law generally is defined in chemistry, but I note exponentially factor alpha D This is the absorption coefficient. Okay. So when light is travel, generally outside the atmosphere, let's say I not, but this is the distance travel or any any atmosphere or any medium. So this is the attenuation in light exponentially minus alpha. This is the way used for attenuation. Okay, answer is A is correct. Next question is which of the following optical design factors required the solar panel to be installed at an optimum angle to the horizontal surface? Option A, minimize the transmission and reflection losses, minimize the reflection losses only, maximize absorption and minimize the transmission and reflection losses, minimize absorption and maximize reflection, minimize absorption and maximize transmission. Please use common sense and you can easily answer. Yes, you can type.
Sí, sí.
Please type. There is a chat box, you can type. Yes. Others, please answer. Two people are active only. Other maybe answer, please. Solar cell, any material, if the material is absorb more light, then create more whole electron pairs and output will be more. And if you minimize the other losses, yes, absorption should be maximum or other losses should be minimum. So which option is according to C? Yes, C is the correct answer. Anyone has doubt? Please yes or no. Then we will move forward.
No.
So next question, the value of the zenith angle at air mass index of 1.5 is, please calculate. We have already discussed the formula. Let me again write down the formula. This is the, let's see, there is the sun, there is the object, this is height h and shadow is s. So cosine j, 1 cosine z equal to 1 plus s by h. This is the formula, or generally equal to a. Please calculate. So let's found index m is 1.5, 1 upon cosine z, or 1 upon 1.5. Do we have calculator? You can use calculator. Let me use 1 divided by 1.5 equal to 0.666. Take cos inverse. Yes. This will be around cosine inverse 166.7 48.189 approximate 48.2 degree. Yes, clear. We can find like that. Please calculate for 2 m2. Just that question may be asked in an exam. So please practice. Please find the value for 2 m index is 2.
60 degrees, right?
Cosine z, you can easily find cosine z equal to half 0.5. So 0.5.
Or 60.
Please answer. Please. Hold this theta equal to 60. So you can find easily like that. Yes, we can move forward. So answer E for this, and this is the definition we have already discussed. I think this is the total representation. There is a picture we can visualize. This is the M0 when sun is directly at, or we can say zenith at zenith, sun above the atmosphere is called M0. M1 when sun is at zenith, directly the sun radiation, and when sun is 48.2, cold is 1.5 am, and 60 for m 60.1 or 60 m2, and move for the both side. Okay, so for solar cell average will be taken, and 1.5 is the universal constant for solar cell when we measure the efficiency. Okay, next question is also, please, sorry, check this question please. If you know, please solve. Sir, I think already discussed in class solar velocity. What is the value? Okay, I will discuss it later because there is a formula for this. Let B is the answer. Minus plus is only difference. Let me first discuss this question. Declination angle. Yeah. So you have to find this is the formula for declination angle. 23.45 sine 360 divided by 365, and is the number of day of the day 284 plus, and this is n is will be calculated in for constant value. Okay, So after put the value and you can easily find. Please write down this formula and solve the previous question. Yes. So let's go previous question. Yeah, you can find by yourself. You have a 5 minute, please solve. If you know the formula, you can put easily and summer solstice. When will be happen? Date? June? Which June? Okay, so please find, put the n value and you can easily find. Anyone please solve this question. We can discuss after. Let's move further. Option B is correct. This is interesting question. Calculate the available energy range for visible solar spectrum. Which spectrum is useful for solar cell and why? Please think. A semiconductor has a band gap. You know, there is a conduction band
Yeah,
and valence band.
point
Conduction band,
point five to
valence
valence band.
band. Let me
No,
tell
the
the interesting thing first.
valence band at the bottom. Valence band at the bottom. Conduction band at the top.
Yeah, you are right. You are not sleeping. Thank you.
No problem.
So this is the valence band and this is the conduction band. For semiconductor, there should be a band gap. This is called band gap. Okay. When sunlight is incident and excite the electron may be jumped from valence band to conduction band. This is available for conduction. Yes. So minimum
Yeah.
this much energy should be required. Minimum. Yes. If energy below this, so any solar cell doesn't work. So solar cell material. What is the semiconductor band gap range? Silicon.
Silicon is 0.7, 0.67 kind of thing. 0.67 electron volt.
6 7 not sir. H,
That's B is the
high.
correct answer.
Yeah. Silicon not much high. 1.1 electron volt.
Silicon is 1.1, yeah. So germanium is 0.7. Huh?
Less than the 3 electron volt uh, uh, line semiconductor, other insulator above the. So let me discuss this question, how we can calculate.
Mm. So I think
Yes,
we can use that formula, right?
yes, let me discuss. If we know that E equal to H by lambda,
Yes.
and what is the constant H value, what is the C, after put the H and C value, we can put lambda for energy range visible. Visible range is approximate.
So
We can see
375 to 7,000.
700
700, yes. Nanometers.
approximate. Not so 6.62 something 10 to the power minus 34. Please, I'm not written unit. Generally SI unit.
Joule second.
Meter per second. Okay. Joule into second. So after put this value, please remember 1240 per nanometer.
Yes.
This is E in electron volt. Simplified formula. After put H and C and convert into electron volt, we can find this formula. 1240 divided by lambda in nanometer, and E is electron volt. You can find easily after put this value and multiply and convert it into electron volt divided by E electron volt 4. What is the value of electronic charge?
1.6 into 10 power minus 19 coulombs.
Okay, thank you, sir. This much charge will be there. So after divide by electronic charge, putting the Hc value, and you can easily find 1240 by lambda in nanometer, E in electron volt. So let's calculate energy range for visible. First put 700 nanometer, 1240 divided by 700. What is the value? 1240 divided by 700. Around 1.77 or maybe lower. 780 I think is the last limit. Visible range, please find the value of wavelength of visible range, then divide 1.58 according to the 780, and for 375 240 divided by 3.3. Okay, you can find, put the value of lambda. So 1.58 to 3.3 according to option A will be correct. Yes. So please remember this formula. 1240 divided by lambda in nanometer, E in electron volt, and you can easily find the range. Any, let me discuss another question for this. Question will be like that. Let's say silicon solar cell. We have a silicon solar cell and has a band gap 1.1 electron volt. And what is the useful spectrum for this? When will be silicon is working or not working? UV range, visible range, infrared. 240 nanometer. You have a lambda 240 nanometer. For this wavelength, silicon is working or not? Silicon solar cell. Question is that clear? Is silicon solar cell is give output or not?
It will give.
So please find first the energy. 1240 divided by lambda 250. What is the value?
It's almost 5.
496 electron volt.
Yeah.
So for this wavelength, can this much electron excite the conduction valence band electron of silicon for conduction? You have a 496 electron volt energy of photons for this wavelength 250 nanometer. Yes.
So it will produce. Mhm.
So
It will produce electron hole pair. Okay.
yeah. Can create electron volt pair this much photon. Let me check it. And another wavelength, this is lambda 1, let's say lambda 2 equal to
1600.
another is 1250 nanometer. For which
So
lambda
it will not.
solar cell is work? For 1250, what is the energy according to this?
Will not.
Do not.
It is
Why?
less than 1.
Because energy
Energy is less than the band. Check it.
9 2 eV. If the photon does not have energy and gap, then any electron will not generate. Yes. So if the photon has energy higher than or equal to the band gap, then only solar cell is work. So our semiconductor has band gap lying visible range generally. Yes. So this is the useful spectrum. or some part of infrared. Yes. So such type question may be asked in exam. So other, let's discuss angles. Latitude angle. What is the latitude or elevation angle? This is the pictorial representation. And question is, which of the following is the angle between the sun ray and its projection on a horizontal plane? This is the horizontal plane, and this is the sun ray. Angle between sun ray and projection of horizontal plane is known as altitude angle. Let's I have a interesting thing to use this. This is the site for TV education. You can find this is a good site. You can find the video or visualization more. Let's see. Are you able to see? At sun and sunrise and sunset, the elevation is 0. Maximum elevation angle occurs at solar noon. You can see. So this is the there is so many angles, latitude angles, zenith, declination. Please see this. The Earth does a 360 revolution as it goes around the sun many more than on Earth. Sun move like that. Oh, sorry, Earth move like that. Are you able to see video?
Yes.
So first visualize and see clearly and learn the definition also of the angles. Sir, I think already discussed in class. Please go to the sir lecture also. Okay. Azimuthal angle. So let's discuss one by one definition. This is a altitude angle definition. Sun ray and its projection on horizontal plane. Angle between. Okay. And azimuth angle. Angle made in the horizontal plane between the north-south line and the projection of the sun ray on the horizontal plane. This is the range minus 182 plus 180. Horizontal plane, angle made in the horizontal plane between NS line and projection. Are you able to see this angle? This is north to south line and projection of the sunlight on the horizontal plane. This is the angle azimuth. Okay, and there is formula. Clear? Please remember this definition. The azimuth angle is compass direction from which the sunlight is coming. At solar noon, the sun is always directly south in the northern hemisphere and directly north in the southern hemisphere. At the equinox, the sun rises directly east and sets directly west, regardless of the latitude, thus making the azimuthal angle 90 at sunrise and 270 at sunset. Next, declination angle definition. The declination angle of the sun is the angle between the equator and a line drawn from the center of the earth to the center of the sun. You can see the declination angle between the equator. Let me find out the and line draw from the earth center to the center of the earth to the sun. This this angle is known as declination angle. Okay, and here is the formula: 23.45 sine 360 by 365 and plus 254. Yes, sir. Your voice is not clearly shown. You can write in chat box. Another information here. There is a summer solstice in the northern hemisphere at the angle theta is a maximum 23.45 and spring equinox 0 and winter solstice northern hemisphere minus 23.45. Okay, the declination angle denoted by delta varies seasonally due to the tilt of the earth on its axis of rotation and rotation of the earth around the sun. So you may please unmute. Noise is there. If the earth were not tilt on its axis of rotation, the declination would always be zero, and however, the earth is tilted by 23.45 and the declination angle varies plus or minus this amount. Only at spring and fall equinox is the declination angle is equal to zero. Please find this question. Please solve this question. The approximate value of the solar declination angle on March 22, 2014 is. You have 5 minutes. And how we calculate a day of the year? Calculate from first January. Please solve. You have a 5 minutes. I will come back in 5 minutes. Yes, please. Are you able to?
Would you please repeat the question?
Please find the declination angle for 22 March 2014. 24, sorry. So you have to put only n value. This is the formula, and let's discuss. 22 for March, number of day, January and February, and for first January, n equal to 1. Okay, January, February, and March 22. Put this is 80 days, and put this value here, and please you may write minus also formula like 23.45 sine 360 divided by 365 and minus 80 also.
Sorry for the interruption.
Yeah.
As joined first, would you please explain the basic of this formula?
Yes. You may refer also the sir lecture, and but there is a declination. You can see declination on Earth. However, the Earth is tilted by 23.45, and declination angle varies plus or minus this amount only at the spring and equinox. The solar declination is 0. So we know the Earth is tilted by 23.45, and this much amount varies. Angle varies this much amount. Okay, when day by day Earth is rotate or by sun and day night happen. So this much amount, because Earth is tilted by this much 23.45, and this is the sine 360 by 365, n is the number of the day, and minus 80 or plus 284. You may refer lecture, sir.
Okay, got it. As Earth is moving, so
Yes,
the tilt angle is also moving.
yes, yes.
Also very
Let
got it.
me show you visualization mode. I think this is the declination. Okay.
Actually, today is the first day
Mhm.
in this today is my first day in this lecture. So
Okay,
I,
okay.
I have watched
Yeah,
Sir's
you can.
lecture.
Yeah, yeah. So you can see.
Sir, Sir has already given the lecture.
Yes, yes, yes. There is a recorded lecture uploaded by in NPTEL site. I think NPTEL site course module.
Okay, I
You
will.
can find. You can see there is a rotation with tilted of the Earth. Yes.
Okay.
Are you able to see my screen?
I'm able to see clearly.
Okay, okay. Thank you. So you can visualize there is axis and tilted. You can visit this site. This is you can find anything. PV education. Please note down. If you are not able to visualize or you want to see further more clarification. Okay. Let's move. So answer is clear. Declination angle 3.618, or you may write delta equal to 3.62 approximate. Okay. So
Okay.
answer is B. Clear? Can we move further?
Yes, you can.
Next is hour angle. The value of the hour angle at 3 p.m. local solar time is, this is the formula and this is the definition of the hour angle. The hour angle converts the local solar time LST into the number of degrees which the sun moves across the sky. By definition, the hour angle is 0 at solar noon. Since the Earth rotates 15 degrees per hour, each hour away from the solar noon corresponding to the angular motion of the sun in the sky by 15 degrees. In the morning, the solar angle is negative and afternoon solar angle is positive. This is the formula. So please find LST is given 3 p.m. means 15 according to 24-hour clock. Yes. Please put this value and find, please solve this question and answer the question. Sanchi and other. Easy. HR equal to 15 degree LST. This is the degree in 12. 3 This is 45 degree. Yes. Easy. Let's move further. There is a solution. Option C is correct. Yeah. What is the value of equation of time in minutes for a location in Goa, 15.29 north and 74.12 east on May 30th, 2023? Sorry. Uh, First, you have to option C. Do you know the formula? Anyone? So first, learn the formula and understand question of time. This is the formula: 9.87 sin 2b minus 7.53 cos b and 1.5 sin b in minute. B is the 365 and minus 81. Then calculate the number of days from 1st January, February, March, April, May. 150 days. After put the value 150, this is the B 68.05 and 2B 2 times. And put this value in this formula, you will get the answer. Please solve now. Let's say do not have this solution. Only this is information for you. Now please solve. First calculate n, then put n value this here, and please find variable or not. Let's see. Please, anyone? Are you there? So this is the formula. and only we have to put B in this question, and B is this, and B is 150. Sorry, N is 150, and according to this, after put the number of N, number of days, we will get P 68.05 and to be this. Put this value B in this equation first, and you can easily solve 2.64 minutes. Clear? Can we move further? Please respond. Anyone in chat, or you can unmute. Guys, are you there or not? Let's move further. Question is the maximum day length on March 22, 2022 in Kanpur, India. Located at altitude and longitude 26.45 north and 80.33 east respectively will be. And this is the formula. You have a 5 minutes, please solve this. First, you have to calculate declination angle delta. We have already discussed delta, how we can, and see 23.45 sine 360 by 365 and minus 80. After find the value delta, and phi is also given here. Put this value in this equation and please find. You have 5 minutes for this question. Yes, that question may be asked in an exam or assignment may be there. Exactly not same, but some data might be different, but question like that in assignment also. First, please find the delta declination angle. So what is the value of n for March 22, January, February, April, and March? January, February, March, sorry. Let's say n equal to 80. Put the n value, sine 0, this is 0, sine 0, given. Okay, what is March, February, sorry, 39 for 2022. How? 2081. What is 81? I think we have already discussed declination angle in previous question. Yes. Some correction might be there because this is 80, this is 80. But this is what is the value of number of days for February for 2024? 28 or 29? Maybe 29. It will be 29. So 81. Think some correction. Please find it again. So you know the formula. If you put the value in formula and you will easily calculate. Here also there is a formula. Put the n value. Let's say here is a for 30 March. There is a typo error. Now calculate the number of day and delta declination angle. After put the value of delta and phi is already given here. Latitude angle. Put this value in this equation. You can easily calculate 2 by 15 cos inverse tan declination angle and then latitude angle. Okay. Any doubt? So I think this is the last question. I will correct this typo error and I will upload this assignment, this solution and video also, recorded video. So please interact in session and in exam how to find out value in sin cosine. Maybe calculator will be there. Let me ask. Oh, professor. Then I will tell you in next session. Any other question? Yes, please. So I think this is the last question, and thank you.
Okay, sir, there is one question.
Yes.
What is altitude angle? Like altitude angle is not clear to me.
Let me. Okay. You can visit this site. And there is tilted. Maybe there or not. Azimuthal. Latitude angle. Are
Yes,
you?
sir.
Yes. So
Alpha. Altitude angle.
altitude or something else.
Yes, altitude angle.
Okay. So first is definition. Let's see which of the this is the definition. Angle between sun ray. This is the sun ray and its projection on horizontal plane. Let's say this is the horizontal plane. Okay. So projection of this, let's say there is a object. Shadow of this object on horizontal plane. Angle between this ray and shadow of the object is known as altitude angle.
So the problem is the projection could be drawn in any direction. Why it is drawn in the right direction?
So like here is the more visualization. Elevation also known as. Please see this animation. Maximum elevation angle is occur at solar noon. How? You can see this is the projection on horizontal plane and sun ray. Are you able to?
Yes, sir. Yes.
So sorry. Here is you can see also. Please visit this site and find out your doubt. If you are not able, then we will discuss again in next class.
Okay, sir. Thank you. Okay, sir.
Okay, and you may visit sir lecture.
Okay, sir.
Okay, okay. Thank you for your interaction. So let's stop here.
Yeah, thank you, sir.
Okay, okay.